Hello, everybody. Oh, there you are. Hooray. Hello, everybody. It's me and Lewis. We're doing a live stream today. Hip, 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 hooray. Hooray. StatQuest and Serrano Academy. Here we
Yeah.
are. Bam. Double bam.
Double bam.
All day long. Anyways, is anyone there?
Hello, everybody.
Can
I see we
someone
have
put
some
something in the
people
chat?
joining. Why don't you tell us where you're joining us from in
Yeah,
the
tell us where you're
chat?
from.
And meanwhile, we'll just be here chatting. So,
I'm
hi,
in.
Josh.
Hello. Hey,
Very
Lewis.
happy to be here with you in
Ah,
your wonderful channel. I am a huge fan.
I'm a big fan
So,
of
this is
yours.
very exciting.
Chapel
Yeah.
Hill, NC.
You're in Chapel Hill, North Carolina, and I am in Toronto, Canada. Yeah. Let's see. I'll be here. Oh, 56
We got
people watching.
Columbia,
So we.
Missouri. Oh,
Oh,
look at
great.
that.
That's close to. I'm from Colombia, the other one, the South America one. I'm in Toronto, Canada. We have from India. We have
India.
Colombia.
DRC. Holy
Benito says hello
smokes.
to
That's
the
awesome.
DRC. Wow.
Yeah.
Lubumbashi. That
East
close to
Palo
Kinshasa
Alto,
or
Greece.
East Palo Alto, right? Greece. Wow.
Cool.
People from everywhere. I'm so happy to see everyone here.
I'm loving it. Switzerland. Hooray. I'm
Switzerland.
actually going to be in Switzerland next week.
Yeah, you will. Nice.
Warsaw. Wow, cool.
Warsaw.
Wow, we
Very
have a very
cool.
international
Guayaquil,
Ecuador.
Ecuador. Nice. Bam.
Serrano, you might have to do some Spanish for him.
I need a catchphrase in Spanish,
Yeah, it's
like
true.
a bam in Spanish. I wanted something like ay
Yeah.
caramba or something like that. I feel
Ay,
like I should do
caramba.
that when I reduce the log loss. I just go ay caramba. We got Saudi Arabia, Brazil, Italy, Argentina, Taiwan, Uzbekistan,
Oh my gosh.
Bangladesh, Dhaka. Wow, this is from
So
literally
many
everywhere in the
cool
world.
places.
Tunisia, South
Oh my
Africa.
gosh.
I
Syria,
am very
wow.
excited.
Hooray.
Syria, that's awesome.
Well, Lewis,
All right,
should we just dive right in? Look, I mean, I'm super excited. We got a
Let,
completely global audience, it sounds like. Holy
let's dive
smokes.
right in because we got
Yeah.
people from Palestine,
Holy smokes.
from Greece,
Greece.
from Morocco, from
Yeah.
Vietnam.
Uzbekistan, Vietnam.
Hi, Irene. Yes.
Anyways, so we took some questions. We're going to try to get some questions in the
Yeah.
chat as well, but we've got some questions that people posted in advance. And the first one comes from Temporary for Study.
Yeah.
And they ask, how do you get a job in AI? Lewis, do you have any tips on how to get a job in
Um,
AI?
yeah, I feel like AI is interesting because it got people from every background, right? I've worked with psychologists, I've worked with philosophers, I've worked with any kind of people coming in from with their ideas. So I think if you have a field that's something that you like, go through it from there.
Yeah.
I would say there's a lot of courses out there. Coursera has courses, Udacity has courses, videos like obviously your channel.
Yeah.
Just check out my channel as well. That's a good way to learn. Hands-on, I would suggest Kaggle, for example, is pretty good for hands-on. But I would say, yeah, go in with your goals and the things that you do in life and try to see how to apply them. Try to if it's LLMs, just go on LLMs, ChatGPT, and things that prompt them and basically get hands-on. So a combination of courses and hands-on is pretty good. Do you have any
I've
suggestion?
I'm going to be honest. I've got a YouTube channel, and so I haven't applied for a job for a little while. But I used to be at Lightning AI, and I know one of the things that they were looking for were like super solid GitHub sort of repositories. So if you obviously you need to learn about AI, but another thing you need to do is kind of create a portfolio of work. That demonstrate that you know what you're doing, and also maybe demonstrates that you know how to collaborate with other people on group projects. And so what I've been told is that you create a GitHub account and you use that to develop a portfolio of projects that you've worked on and code that you've written, and you can kind of show off like how good you are at commenting and explaining the code. But you can also collaborate with people. And I know recruiters are looking for these things, or where they kind of see this as like self-initiative, but also able to work in a group and understands what are those things? GitHub. That seems to be an
Mm-hmm.
essential thing. In addition to understanding the actual AI and large language models and all
Mm-hmm.
those things as well. So those are some things that I think of like a way to like make you stand out from the crowd. And I know everybody does those things, but it's worth reminding, and just treat it like it's your resume. It's something you want to look really special and you want to be very professional.
Mm-hmm.
And that doesn't mean you can't have your own personality, but treat it as if like you're expecting potential employers to be looking at this thing.
Mm-hmm.
Um,
I dropped in some good answer. I dropped
yeah,
in some resources in the chat for practicing for interviews. HackerRank is really good.
awesome.
Kaggle, LeetCode,
Yep.
Euler Project. In order to study for my first interview in AI, which was at Google, I just did a lot of HackerRank problems.
Okay.
So those really help.
Bam. And
Yeah.
Lewis, you've worked
Damn.
all over the place. You were at Cohere.
Yeah.
I didn't know you were at Google.
I was at
Um,
Google and Apple for
Google
some
and
time. Yeah.
Apple. So I mean,
Yeah.
holy smokes.
Just here and there.
Just here and there.
I tried different places and
Yeah.
zigzag. It was fun. Yeah,
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 it's amazing. Very cool.
yeah.
Um,
Thanks. So actually, I see some math questions, but I have one for you that I want to ask you.
okay.
I want to ask you, how'd you come up with StatQuest and the normal Saurus? And it's a loaded question because the next part of the question is, and can I suggest one?
Yeah, so Stat Squatch and Normal Saurus. Yeah, golly, Normal Source came from a T-shirt design that a friend of mine's daughter created a long time ago. She was really young, and she was artistic, and I asked her to draw something for Stat Quest, and she came up with this dinosaur that had a normal curve as a
Oh,
background, and I just loved it, and so that's where the Normal Source originally came from, and Stat Squatch came as a I thought it was hilarious the way it sounded, but also uh, I felt like when I'm creating these stat quests, um, I'm learning as well, and I ask when I'm learning the new material. I ask a lot of not dumb questions, but I ask a lot of questions, and basically Sasquatch is me. Sasquatch is me, like, and that's who I was when I was learning the
mm-hmm,
material to
mm-hmm.
begin with, and so it's a way for me to sort of like take a step back and go, okay, assume you don't know the material. What kind of questions would you have? And I go, well, these are the questions I had. And then I
Yeah.
go and I give those to Stat Squatch. So that's the story of Stat
Mm,
Squatch and the normal
nice.
Saurus.
I love it. I feel like I identify with StatQuest as well because I have asked a lot of basic questions. Still,
Yeah.
I just, yeah, with my friends, I just keep asking them stuff,
Yeah.
asking. So here, how about this? Let's
Yeah.
say you have a logarithm function. Let's say you have a log loss or something, and you
Uh-huh.
have a hidden logarithm. So
Uh-huh.
how about this?
Yeah.
The logness monster.
Oh my gosh.
And then the neck is the logarithm function graph,
I
right?
love
Like,
it. I totally love it. I totally love it.
so feel free.
Yeah.
It's yours.
Oh, I'm gonna have to do that. I'm gonna have to use that. I'm gonna actually write that
and
down.
and the Loch Ness monster lives in what country?
Scotland?
In Statland
Yeah,
that you have
Stat.
in
Of
your
course.
which you have in your videos.
How could I forget? How could I
Its
forget?
flag is got is the flag is the letter X. I feel like Scotland has so much potential for math puns. It's just limitless. But anyway, so yeah,
I love it.
that was the suggestion.
That's so good. I love it. I love it. I love it.
Cool.
Lives in
All
Statland.
right. What's the next question?
So the
I
next
see.
question, and I get this all the time, and I almost have videos that explain this. And Lewis, I think you might have a video coming out that explains this. So the question is,
Yes.
why do we divide the sample variance by n-1 instead of n?
Yes. That has driven me crazy for many years. I've been thinking actively for 10 years about this.
Yeah.
Because it's weird to divide it by n minus 1, right? And I've asked everybody, and I bring it up in conversations with friends. It's like, hey, how about that Bessel correction term? And people are sick of me asking this. And there's two schools of thought. So basically, what's the question, right? Like, what's the variance of a distribution? It's a measure of how wide it is, right?
Yeah.
So this distribution, very narrow, has low variance. This wide one has high variance. And the way to measure is to take the middle, the mean, and see how far points are from the distribution on average. So you take the average square distance. There's a problem there, which is we don't know the mean. Asking for knowing the mean is too much.
Yeah.
Right? And the two schools of thought are the Bessel correction term says if you want to estimate the mean, take n points, take their average distance from the mean, and don't divide by n, divide by n minus 1.
Yeah.
And that drives me crazy.
Yeah.
And there's two schools of thoughts. The one that says that you just work out the math and it cancels out and it's n minus 1, which doesn't make me happy at all. And there's the other school of thought of people who say, well, there's n minus 1 degrees of freedom because you have the average fixed, and so therefore you divide by n minus 1, which I don't get that big jump.
Yeah. Yeah.
So here's what I think. I think I want to define the variance in a different way.
Okay.
So don't think of how far you deviate from the mean because you don't know the mean.
Yeah.
Think of how far points deviate from each other. So pick two random points, their distance squared, and take the average of all the distance squared. That tells you how wide the curve is, right? And that's not the variance, but if you work it out, it's twice the variance.
Oh.
So I can take the average distance between 2 points, divide it by 2, and I get the variance for a distribution. Now for a data set, take n points, take the average of the differences between them. How many pairs of points are there in n points? Well, the first point you can choose in n ways, and the second one in another n ways, so n squared. But I don't want repeated points because I don't want x minus x. So instead, I pick the first point in n ways, the second one in n minus 1 ways.
Yeah.
That's the Bessel correction term. So I shouldn't divide by n squared, I should divide by n times n minus 1. So if you define the variance like that, like differences squares, then the Bessel correction term is obvious. But if you do it in the other way, I still haven't been able to see that in minus 1. So a video is coming up pretty soon in my channel, which is in the links, I think. So yeah,
it's gonna be awesome.
Thank you.
Ah, so cool. Yeah, I love that.
Yeah.
Moving on, I guess.
Let's see next question.
There's nothing I can add to that.
Cool, thanks. Yeah, I've been, and definitely I'll let you know when the video is out because it'll be out in the next few days. There's the next question by NHSun1902, wondering about real-life applications of eigen decomposition in machine learning.
Yeah.
Do you have any thoughts?
Well, when I think of eigen decomposition, I think of principal component analysis, and even though principal component analysis doesn't act, I mean, they used to do it with eigen decomposition, and now it's done with singular value decomposition, but it's still two roads to the same end. I think of that, and I think of PCA as a denoising application. It's a way to, I mean, data sets are if they're large enough, tend to have a lot of noise. I mean, even if when they're small, they're noisy as well. But we get these really high dimensional data sets these days. And by high dimensional, I just mean we've measured a lot of different things. For example, for me, you could measure my weight, you could measure my height, you could measure my hair color, you could measure my vision, you could measure my blood pressure, you could measure all these things about me, how long each finger is, the size of my nose. We could have all these measurements. And how do we, some of them are going to be useful and some of them aren't going to be useful in order to, for whatever your AI or machine learning application is. And we don't want to feed in sort of useless information into our ML algorithm or AI. And so one thing we can do is we can denoise that data with PCA. What PCA does is it basically takes all the data, all of the things that we've measured, all the variables, and it kind of like reduces it down to just a handful of very useful things where it creates new variables in the process. It creates new eigenvectors and the eigenvectors are most likely going to have a lot more information in them sort of per variable than maybe the original variables.
Hmm.
So I think of that as like the classic use of eigen decomposition in machine learning.
Yeah,
Um,
yeah, that makes a lot of sense. I think
yeah.
PCA is the.
UMAP and TSNE, these clustering
Hmm.
algorithms, or
Yeah.
not really clustering algorithms, but they're like way of visualization algorithms that allow for non-linearities in the data. Even those
Yeah.
often will have a PCA sort of denoising step early on.
Hmm. Hmm.
And so it's just sort of like a classic approach. Um,
Yeah, that's definitely the one. Yeah, it's yeah, and I think you can find like correlations between the data, right? Like if you have a measurement in you, like if you figure out that the nose is the same as the forehead, then you only need one of them, right? So you kind of remove redundancies.
yeah, yeah,
So yeah, yeah, yeah.
what
Good
else?
answer. Next question.
Yeah.
We have Joy Jester. Use of multimodal LLMs in embodied intelligence and agentic workflow. So I can add something here. Yeah, I think so. The question is about agents and workflow in LLMs. I think that's the next step, and it's happening, right? Like it's the
Yeah.
next because LLMs, what they do, they talk to you and they talk back, right? It's like having a friend who talks and tells you what to do, and then you take that and do something. But agents are definitely the next way to go, right? Like which is when they actually go and do something. So
Okay.
RAG
Yeah.
RAG is the first sort of agent, which is it. You ask it a question and it doesn't just answer because it may hallucinate,
Okay.
very likely. It instead just goes search on Google or on Wikipedia or on your own database and then comes back. So it does one thing. That's a huge step, right? It does one thing. If you ask it a sum, it could answer it with text, or it could just go look for the calculator app and do the sum and come back, right? Much easier. It goes and writes, code and compiles it in a certain place, or tests the code, writes a unit test. Those things are not done at the language level. They should be done at the tool level because we have tools for that, right? So yeah, opening mail, for example, send a mail to somebody, add this to the calendar app, like that. That is definitely the way to go, and it's operating with agents. And then you can do things like you can even make answers better like that. For example, if I ask it code and it writes code, that could work. But if it goes and runs it and comes back, writes a test, runs it, comes back, uses a tool to give me a response, that's even better too, right? And then when we're looking about multimodality, we're looking at sort of what the models, they only is text in, text out, but we don't learn like that. We learn from images, we learn from sounds, we learn from all these things. And we have workflows, right? Like you could have you could put in a prompt that says take this figure, extract something, and make a sound about it, a voice, say it in voice, right? So you have like sort of chains of thought, and agents collaborating with each other. So yeah, that's definitely the next big thing we're gonna see is after languages is agents.
Very
Yeah.
cool. Very cool. Um, I'm going to skip around on the questions.
Sure, go ahead.
Arash Badi. I'm really bad with names, so I'm going to mispronounce everybody's name. But anyways, they
I'm the same.
asked, could we talk about the use of transformers in omics technology? So omics technology is my background. A lot of people may or may not know this, but I used to be a professor in the genetics department at the University of North Carolina at Chapel Hill. And in genetics, we have something called omics data, and the omics comes from the genome. We used to call the human genome, or we could say, and we say genomic data. It's a genomic data. It comes from the genome. But then there was what happens inside of a cell is the DNA, that genome that we were talking about, is transcribed into RNA. And RNA is a different type of molecule, and you don't need to know too many details about it, but you get a lot of it in your cells, and we can measure the RNA to understand what the cell is doing. And so they would call that transcriptomics. And so they kept adding this omics, and if they were studying proteins, and then they would say that's proteomics. And so we would just stick this suffix, this omics, onto whatever they were studying. And basically, the word omics meant lots of data in that subject. So if we've got lots of gene data, genetic data, we call it genomics. If we have lots of RNA or transcript data, we call it transcriptomics. If we have lots of protein data, we call it proteinomics or proteomics. Someone asked about the use of transformers in omics data. So anything biological where we have lots of data. And actually, I was just talking to a friend of mine, Luca Pinella, who's a professor at Harvard. And he had recently made a publication using a language model to generate sequences that could control genes. And I know this is like very esoteric, and we're going to dive into a little bit, but in every single cell in our body, we have genes that do everything. So in these skin cells, I've got genes that can create parts of my eyeball. I've got genes that can create parts of my teeth, my tongue, my internal organs. So my skin, even though all it does is hey, I'm just skin. All I do is skin. I don't do eyeball. I don't do stomach. I don't do tongue. But it has all the genetic information in there. And one of the problems with, say, cancer is that a cell forgets who it is. It's like, oh, I used to be a skin cell, but now I don't know what I am. And in that state, they can transcribe anything. They can turn on any gene they want, and as a result, they can start taking over and doing things they shouldn't be doing. And what he's doing is he's using a large language model to create sequences that can turn on and turn off and regulate genes. Now, so for example, say like I've got a skin cell, but what I'd like for it to do is I would like for it to create sort of stomach secretions. I don't know why I would want to do that, but he's got a way of basically coming up with a sequence of code that's based on an LLM. So that's one of the, I don't know too many things, but that's one of the things I know that's going on in terms of transformers and language models and how they're being used with omics data. And I know that was a lot of explanation for a little bit of like answer, but that's the best I can do right now.
That's fascinating. I didn't know. So you can use an LLM to like sort of study big sequences of DNA?
Yeah, exactly.
Or of,
So the BERT, I don't know if you're familiar with the BERT LLM. It used to be, it was originally sort of trained as sort of a language specific LLM. But now it's used because it's really good with relatively long sequences. They're just feeding it tons and tons of genomic data, and by that I just mean long sequences of DNA from our chromosomes. We've got billions and billions of these base pairs connected to make a sequence of A's, T's, G's, and C's, and we can feed that in and say some of these sequences do this, some sequences do that. And we feed it in, and then once we've trained it, we go, or fine-tuned it, we say, okay, based on what you know about these other sequences, can you create something new that will cause this stomach enzyme to be transcribed in this new, situation and the new environment? And it's, and the amazing thing is it works. It totally works. It creates these novel sequences, and you can have a cell do something it shouldn't. You can also remind a cell to not do something, it shouldn't. And you can make it, and you can also do it you can say, I want you to do this in this setting or in this time frame or something like. You can do all kinds of crazy control over how the gene is used, and it's pretty remarkable stuff. So that's
fascinating. I feel like I have hours and hours of questions for you. Yeah.
We'll save that for another
I'll
one.
save that for next time. But if anybody has follow-ups on that, I would I would love to hear more. Yeah. By the way, there's a couple of comments. I hear you very well, but a couple of people, your microphone could be turned up a little bit. Is that possible? And let us know I hear you very well, but if anybody wants to let us know in the chat if you hear us both well.
Loud enough for you? I'm putting that in the chat.
Yeah. Is that loud enough?
Hopefully people can hear me better now.
I think so, yeah.
Anyways, we have one more. Lewis, I have a question for you, and it's also a question from Brain Eater Zombie 3981.
Okay,
And
that's
they
a pretty
go,
good.
and the
I
question
better
is,
answer it properly.
yeah, exactly. You watch out. The question is, Laura, how it works.
Yeah, yeah, great question, Brain Eater Zombie 3981. I've been reading up a little bit on it, and it seems
Yeah.
like a pretty clever. I'd love to hear your thoughts on it too. It looks like a pretty clever way to train a neural network. Because when you're training these transformers, you could have trillions of parameters, which is awful way to train and to fine tune and anything like that.
Yeah.
But they started noticing that they are lower in dimensionality. So, for example, what you were talking about, PCA, right? Like I could have a data set that is flying in two-dimensional space that I need two variables to explain it, but maybe it's all in a line, so I really just need one variable to explain it.
Yeah.
I started noticing that these layers on layers of the neural network, which have many parameters, were kind of flat in some regions of space. So they're easier to, you can explain them in less variables. As in, like if you have a big 10 by 10 matrix, I can explain it as, I can factor it as a 10 by 2 and a 2 by 10, and all of a sudden I have a lot less parameters to get really close to the matrix.
Mm-hmm.
So it seems to me that what they do in LoRa is that they just pass it through a funnel, pass it back, don't lose most of the information, and train a lot less parameters. So it's low rank. What is it, Laura? Low rank something. I think that's what it pretty much does.
Yeah, and so my understanding is, so you have a large language model, and yeah, it might have 375 billion parameters, right? And so training or fine tuning, like Lewis just said, is incredibly time consuming and expensive. So what they do is they basically create sort of an adjunct that has relatively few parameters, and they fine tune that. And you can
Yeah.
have this model running, whatever your big model running, but in order to have it, because one thing we want to do when we're fine tuning is we take a general sort of like foundation model, something that's been trained on all of Wikipedia and all of the internet, and we want to do a bunch of different things. Like one, we might want to do a customer service chat bot. Another thing we might want to do sort of like a paralegal assistant bot, which would be a slightly different training. Another one we might want to use for translating English to Spanish, or something like that. Like there's all these different uses of this foundation model, and we don't want to have to train it for each specific thing, because that would take forever. And so instead, they have this sort of like adjunct that they add to the model that's got relatively few parameters that can learn the specifics, and that it's this adjunct plus the full model, that kind of work to give you the desired responses. And so when you're using it, and so say like I could have one model, but just like a bunch of these little small things that are specially trained, rather than many copies of this gargantuan monster. And so I think that's one of the things about how LoRa works, and why people are all excited about it, because it allows you to, with relatively modest means, get a lot more mileage out of whatever large language model you're using. Yeah.
Yeah, I love that.
Should we
Great.
dive into some questions from the chat? I saw a bunch.
Yeah, can I ask you one that came up here, which is
Okay.
also, I'm looking at my
Yeah.
own, the ones that somebody asked for you, was
Uh-huh.
watching your XGBoost videos last
Okay.
night, which I love those 4 videos, by the way. I learned XGBoost like that,
Aw.
and I couldn't learn it another way.
Yeah.
One thing I'm unclear on, are all the weak learner trees fit on all predictors, or a subset like a random forest?
Yeah. So in theory, it's the answer is both. The original manuscript describes testing every single variable you've got, for every split. But in practice, what you do is just like in random forest, you have it select a random subset of variables, and you use those instead. And so that's, so it's a little bit of both. But yeah, they're parameters, just like you have with random forest. There are parameters when you use XGBoost to sort of configure how many variables you want to use per tree, and things like that. Ways to kind of like reduce and add a little bit of basic random forest style building to XGBoost. So yeah, the answer is both.
Great.
Yeah.
Let's Let's see what else. I see a lot of questions about career, so I think maybe
Yeah.
we can answer a few technical questions and then
Yeah.
delve a little more into like the PhD career, etc. Like I think
Yeah. I see a question about
that'd be interesting.
internships, just starting
Internships.
out. Um,
Yeah. Let's
more
see
career
when
stuff. What
evaluating.
courses should you take? What topics should you focus on?
Yeah.
Uh,
Let's see. I'm trying to see if there's a couple of technical questions
yeah.
we can answer quickly. Um, when evaluating variable importance in tree models, is there a way to understand the sign plus minus of the importance? Does plus or minus sign come out in tree models? I feel like in regression models they come out, right? Like if you have
Yeah.
a
I'm
in
gonna
a
say that's a new one for me too. So I
yeah.
don't know if I can answer that.
I feel like in regression I see a lot of negatives, right? Like if it's
Yeah.
not correlated, if I'm trying to figure out the price of a house,
Yeah.
and obviously the size is positive, it's a
Yeah.
positive coefficient because it adds to the price.
Yeah.
But for example, something that's not, crime rate in the neighborhood or something that's
Yeah.
negatively correlated would have a negative effect. I
Yeah.
don't know if that's the question or
It could be if you're using, say, a regression tree. Maybe that's what they're talking about.
maybe
Is
regression
using
tree
a
would have
regression
that.
tree in that
Yeah.
context is this creating a larger output value or a lower output value? What's the effect on the
Uh-huh.
output?
Yep.
Maybe that makes sense. That's a guess.
I would say your
Yeah.
guess is yeah, as good as mine. Probably
It's as
better.
good as mine.
Yeah. Great. I see a question.
Someone says, this is from Mark Watney.
Oh
As
yeah.
time goes, is it possible to get a complete, clean data set devoid of hallucinated data content in order to avoid the Xerox copy of a Xerox problem?
That's a good
Um,
question. What's the Xerox problem?
I actually don't know what the Xerox problem
Okay.
is.
I feel like I'm stat squatch now.
I
Like
know
I'm
exactly.
asking the
Me too.
question.
But
Mark, can you help us out? What's the Xerox problem?
but I wonder if maybe they're just asking us like is it possible that large language models are contaminating our say data set, right?
Mm-hmm.
Because as data, they large language models have learned and on the internet, but now they're generating internet content. And some of that
Yeah.
internet content could be hallucinations. Like I have a friend who's got this website that I think is pretty hilarious called reads.me. And it's basically ChatGPT that creates these listicle articles like top 10 things I love about November or the 33 things we need to do to celebrate the Ides of March. But it had this article that came out like a week ago and I made me laugh because it said 10 reasons Homer Simpson is still relevant in 2018.
I love it. Of course it's
and,
relevant.
and so part of the problem is my friend's website is just generating garbage. Some of it's true, some of it's not. And so I guess the idea is when we train the next level of foundation models that are trained on the whole internet, right? They're going to be training on a lot of this garbage generated that's hallucinated, right?
Yeah.
And so are we just like, if we're just going to end up with things that are worse and worse and more hallucinations until like all information is garbage? Is that a possibility?
It's like a vanishing gradient
That
of
sounds
information.
that's
Just
the
all here.
singularity, right? The singularity is
Exactly.
when there's no information worth anything on the internet. it's all cat
Yeah,
videos.
it's just a void. Yeah, no, I don't know. Yeah, I feel like as humans we're pretty good at generating a lot of garbage and biased data sets and stuff. So
Yeah.
if there's one thing we don't need help and we're getting unwanted help is that. But I feel like yeah, I mean hallucinations are hard to avoid because they're not a bug. They're more a feature.
Yeah.
Like when a model, I like to say that a model doesn't just say the truth and sometimes hallucinate it. It always hallucinates. Sometimes it accidentally hallucinates the truth because you can't store data on the nodes of a neural network, right? These are continuous, right? These are, it's not a database.
No.
So you have to do things like RAG or heavy fine tuning and tool use is very important. But I feel like you can count on language models to hallucinate because they're learning how to speak, they're learning the language, but they're not learning facts. And we've seen things like training data, like having a neural network produce data and then train on that in federated learning, right? When you want to be secure, you want to train a model with people's personal banking data, but you don't want the model to release personal banking data accidentally. And so you just do a few steps of like you generate fake data based on this one, train them all on that, and then so we may it may be that that's a solution for the language model not to accidentally spit out something personal. But at the same time, we run into the problem that you say, which is the vanishing gradient of everything ends up being garbage. So I think it's something to be very careful, and that I hope whoever's doing it is doing it well.
Yeah, yeah.
Yeah, pretty much.
So here's a question.
Yeah.
Mark T asked, "What's the pros and cons of having a bigger model compared to a smaller one if you just use RAG or fine tune it to get it to work the way you wish?"
Uh-huh. So I'm gonna answer with the way what I would have answered a few years ago when they asked me how to train a model. I would have used this analogy of saying you can train a model that's too small or too big. It's hard to pick the right amount. But if you're gonna err on the side of too big, kind of like if you're gonna wear pants with too small, you can't do anything with too small. But if you do too big, you can put in a belt, right? So like you can do regularization. You can like train a model that's too big and then do dropout or regularization or kind of like make it smaller.
Yeah.
I feel like that's the way to go if you're doing it yourself, right? Like I don't know, when it comes to large language models with trillions of parameters, there's probably better techniques. But I feel like if you're gonna
Just put a belt on it.
just go big and see how much you can do with how much computing power you can, and then decrease it.
Yeah, I
Yeah,
think it's probably you. What's your budget? And that's how big it can be.
exactly,
That's how
exactly.
you make
That's
the decision.
how much money do you have? How much computing power do you have? That's yeah, and then
Yeah.
hope, cross your fingers.
Cross your fingers. Exactly
Yeah.
right. Yeah. So if you got the money, spend it. That's all there is to it.
Yeah,
um,
exactly.
we have another, and actually, this is embarrassing. So it looks like we got Nasan Weissman, a good friend of mine, who's actually going to be on my podcast in a little bit. So
Nice.
I'm excited about that. But anyways, he's got a question that unfortunately I don't even know if I can answer. The question is, any papers you'd recommend on fine tuning or leveraging LLMs for specific types of tasks, like law,
Mm.
medicine, math, and I'm presumably that means something other than just RAG, right? Um,
Mm-hmm.
so is there, because that's the whole, RAG is sort of like the ultimate in fine tuning. So
Yeah.
RAG is
Retrieval
augmented
augmented generation.
retrieval augmented generation. I
Augmented
know we've been talking a
generation,
little
yeah.
lot about it, but and Lewis has said it many times, but maybe I'll say it just to remind myself. So the idea is you have a large language model like a ChatGPT or whatever, but it also has access to something that can uh, look in a database and can look online and can look at stuff real time. And
Yeah.
you can say, based on, you can say, based on these sets of manuscripts that are in this directory, give me some answers. Or you could say, based on these clinical records, medical records, let's focus on these things, or these I one example I've heard of is in with like skin cancer, they have lots of pictures of photographs of what skin cancer look like. And I've heard some success stories where people have trained, you could use RAG to say, look at all these pictures of various types of skin cancer, and some of them don't have skin cancer, and you can do plus or minus, and you could then train it, a large language model or some sort of model or transformer um, to then classify, like I just take a picture of a mole on my arm, and I could send it to my doctor, and my doctor goes, well, I don't know what it is, but this model says it's okay, don't worry about it, Starmer. And I'd be like, hooray. Or it could be like, uh-oh, wah, wah.
You
But I
get
think
banned.
RAG might be, rather than manuscripts, I think RAG might be the real thing right there. And I think the interesting thing is, it's not really the technology is the hard thing. I think getting the data and getting the buy-in from, because a lot of that data has a lot of HIPAA compliance or privacy stuff, and that the hardest part with all those things is probably getting the data.
Yep. Yeah, I
Yeah,
agree completely. Sometimes the models
yeah,
only go so far, and data is what helps you. And RAG
yeah,
RAG can get really far or tool use. I had
yeah,
the other day, for example, somebody asked me had in a page of a bunch of products,
yeah,
and I said just ask it use RAG and you'll get any information. What product is this? What product is that? And they said, okay, how do I ask it for the most expensive product?
yeah,
And then I'm like, oh, that RAG doesn't do it because it has to check everything, it compare, like it creates some logic, right?
yeah,
And sometimes, like if you ask RAG for the longest page in Wikipedia, it
yeah,
doesn't compare the pages. It goes to a page of Wikipedia facts
yeah,
and finds it there. So sometimes making your own data better, like if you make a page of facts of your data, this is the most expensive product. Like
yeah.
enhancing your data can be faster and
Oh,
much more
interesting.
effective than enhancing your model or putting a new tool. So I would say
Yeah,
that that's the first place to go. Get the tools that are there.
yeah,
How can you soup up your data
yeah.
to make it work better?
That's fascinating. So it's
Yeah.
almost like you get your data and then you do some exploratory data analysis on your data
Mm-hmm.
to generate summaries of it, generate,
Exactly.
and that's fascinating. I never thought about that.
Cool. Yeah, because
Um,
you know your data better. Like, who
yeah,
knows your data better than you and the problem and stuff. So sometimes enhancing it that way kind
yeah,
of makes a hybrid human machine the best because you have your knowledge and a
yeah.
bunch of tools.
So that actually might
Yeah.
segue into our next discussion topic, which is it sounds like although it's a crowded field, sounds like there's still need for data science, right?
Mm-hmm.
Uh, it's like the LLM. What you're telling me is that the LLM can't do it all on its own. It needs some sort of human pre-processing or some what do they call it? Expert knowledge
Yep.
or expertise in the field. It can't just do it all, and in order for it to work correctly, um, we need those domain experts. And so it sounds like data science may survive the AI apocalypse.
Maybe. I think it is, yeah. And I think if things are getting easier, they're getting easier in the way of the syntax, right?
Hmm.
Like coding is easier, which
Yeah,
you've seen it happen, right? Like a
yeah.
previous generation wrote in assembly
Fortran,
and
yeah, an
yeah,
assembly, and
assembly or punch cards.
yeah,
I don't can't do that.
yeah,
But the concepts, we write Python and things that are easier, but the concepts are just as complicated, right? And the next
yeah,
generation is going to write code in English,
yeah,
which makes me very excited because I think the best data scientist is the one that knows the problem they're solving,
yeah,
right? Like
yeah,
if you're solving a problem in the field, if it's in science, you know that stuff, right? Like if it's in the field you are, if you know that plus how to handle data, I
yeah,
trust that more.
yeah,
So if the syntax is made simpler, then more people can come in and do wonderful stuff with data science. So I feel like it'll prevail, and the data science plus prompt engineering will be sort of the what I think is the profession, the next big profession.
yeah, yeah.
Yeah.
So that leads us to algebra school's question. If you're doing a PhD that's not specifically related to AI, but interested
Yeah.
in AI, how do
Yeah.
you merge the two, and what is your advice? And I'll start with that one, which is just dive in. And the thing is whatever field you're in, chances are there's a way for AI to make it cooler. And the thing is if you're interested in AI and it's like a field not related to tech at all, you're like 100 miles in front of everybody else. You've got a huge head start, and so you can actually pave the way and make a lot of progress and sort of be like the forerunner. So just go for it. Learn whatever it is. Um, learn about AI. You can obviously, I teach it on my channel. Lewis has got stuff. There's tons of academies, tons of boot camps. Get those skills. And then, just like we're talking about, you need these domain experts, and then you will be that domain expert, right? So you're like Beauty and the Beast. You've got it all. So that's a very exciting position to be in, is to be in a field that's not AI but interested in it, because chances are you can use AI in your field and you will be especially if you're at the PhD level, you will be a fantastic domain expert. So that's exciting.
Yep.
Um,
I agree. I think PhDs. I did a one in mathematics, which is not when I didn't know what data science was or machine learning.
yeah,
And yeah, I mean, I think if somebody's interested in doing a PhD, it's because you're interested enough in a topic that you want to dive in it. Do it. Don't worry. Yes, as Josh
yeah,
said, like the odds that AI doesn't go into that field are very, very small. And many times employers, when they see a PhD, they know that first of all you have a lot of knowledge, second of all you have a lot of grit because you push through
Yeah.
something. It means you can push through pretty much anything.
Yeah.
And I think just being very deep in one subject can really help. It's kind of like sports, right? Like if I've played professional soccer for 10 years, have a much better physical state than I could jump into another sport easier than if I just sat on my couch for 10 years, you know what I mean? So
Is that
like
true?
the techniques, as long
Yeah.
as your brain is pushing and as long as you're learning stuff all the time, it's not hard to switch into AI.
Yeah. Yeah.
Yeah.
Yeah. It looks like
Cool.
somebody's. Looks like what's it? Ruben G is trying to start a fight out there. He says, "Lewis, your videos on PCA and SVD are the best
Oh,
ones on those topics."
yikes. I'm flattered, but I really like your PCA. Yeah. So yeah, no.
That's hilarious. No, it's the thing is what I love is there everybody learns differently, and that's what obviously I learn differently from some people, and what I love is one thing I love about what Lewis does is we tend to talk about things differently, right? And
Yeah.
as a it's very complimentary, and so
Hmm.
if my content works for you, great. If it doesn't, what's awesome is
Hmm.
there's a place you can go.
Yeah.
That's gonna be different from mine. It's not just gonna echo me. So you can go
Yeah.
to Lewis, or you can like watch Lewis videos. And if this is awesome and it resonates and you're perfect, you don't need to come to me. After that, you understand it. Stay. But
Mm.
if it doesn't work, you can try me. So it's like
Yeah.
apples and oranges and all these things. But I
I
love
agree.
that the two of us. I feel like what's cool about the two of us is we can reach more, right? Because
Absolutely.
we can appeal
Absolutely.
to different learning styles and teaching
Yeah.
styles and all these things, and so it's really cool.
Absolutely. Yeah, because every learner is different, right? And
Yeah,
some people learn more visually, some people do more the numbers, etc. And
yeah,
I feel like, I mean, it's funny. I feel like I've known you for years because I've seen your channel. This is the first time we have a live, but
I know.
I've seen your videos, and actually, they help me a lot,
Yeah,
and many topics,
yeah,
many things. I go to your channel
yeah.
and I see, okay, if there's a video there, many times it's much better and I don't go for it. Like I've never made an XG boost video because your XG boost is
Oh,
better than I will, or
oh,
things like regularization, stuff like that.
yeah.
And the only times, many times I make a video because I'm like, okay, I have a different story,
There you
right?
go.
Like you have the
Yeah,
story, I have a
yeah,
spin,
yeah,
and you have this story which I actually could not tell. Like
yeah,
I'm not able to tell the story well, the one you have, but I have a different one in my head, and so I put it there. So if
yeah,
anybody sees a video, if you watch your PCA and my PCA, they're completely different,
yeah,
and most of them are completely different because there's one season in one angle and the other one in one angle. So I recommend to people, yeah, definitely. I mean, go to StatQuest, and
yeah,
if you
yeah,
see a video on both, check them out both because they normally tell different stories. We have similar like visual styles, but I think the thinking style is very complementary, and I'm very thankful for that. I
yeah,
mean,
yeah.
I've watched your channel hours and hours and hours and
Oh,
days and
that's
months, so
so
it's
nice.
it's really good stuff.
Hooray!
Yeah,
So we got a few more questions. We got a ton of questions. We
yeah,
won't get to all of them, but I'm seeing some more. And
yeah.
Nelson actually had a follow up, and I feel like we need to because he wanted something other than rag, and we never quite got there. So I feel like we should check his follow up, which is, do you have any specific papers on rag that you'd recommend? Um,
Oh, I
I
have
was
one.
just reading the original manuscript the other day, like
Yeah, yeah,
the
yeah.
initial one, and it's pretty good. So I would actually just start with, you know, the classics.
That's the one by Patrick Lewis,
Mm-hmm.
right?
Yeah.
Yeah, I used to work with him at Cohere.
Mm-hmm.
I recommend that one. He's the knowledgeable, the
Yeah.
person who knows
It's very
about
readable
rag.
too.
Yeah. I hear some question. Actually, there's a question saying, "Do we get to hear ukulele at the end of the session?" So no pressure.
And the answer is yes,
But I
but
think
it's
the
not
answer
quite the
should be
end.
yes. No, it's not the end yet. Somebody says the person who should join us is Jay Alamar. Huge shout out to Jay
Oh,
Alamar.
holy
That guy's an
smokes, yeah.
amazing channel,
Yeah.
amazing videos and blogs. And this is actually a guy that I go to with my AI questions all the time. He has
I was
also infinite patience
I
and
was just
knowledge.
talking to him yesterday.
Nice.
We need to
Yeah, yeah.
yeah, so maybe what we need to do is we could get him on this as well. That'd be,
I
oh my
would love
gosh.
that. I
That
would
would
love that.
that would be
Yeah,
a
yeah,
triple
yeah.
bam.
That would
Um,
be a triple man for sure. Let's see what
um,
other questions there. There's
Uh, Louis, do you know any cheaper place to host an LLM than Hugging Face and AWS?
Host an LLM. Yikes.
Yeah, exactly. Full-time hosting.
What is
Um,
host? Sorry, what is host an LLM? Like using, like fine tuning one
is that like
and
permanently deploying it, like, or is it just to test it out, or
oh, deploying it.
um,
Yeah, I feel like
I
gee,
would
I'm not
think
so
like the absolute
expert on
cheapest thing
deployment.
if it would be AWS because that's what everybody's
Probably.
using. I
Yeah,
mean,
and it's
maybe
also yeah, and it's also you can use the ones from Anthropic. You can use the ones from Cohere. You can use the ones
yeah,
from like OpenAI. I feel
yeah,
like that's a place where it's kind of a one-stop
yeah,
shop. So I would recommend that.
yeah. It says permanently
Yeah.
deploying it. I think if it's a long term thing, that might be the best bet. Um, I mean, I used to work at Lightning, and Lightning was awesome. And one of the things that I think was cool, if you're just training or trying to get it working, is they give you free GPU credits. So you
Mm-hmm.
can just, you can play around with it. But I think in terms of like long term hosting, permanent deployment, you've got it working the way you want it. Uh, um, I you know I don't I think you might want to just like do some bulk negotiations with AWS at that point because that's what everyone's
Yeah.
built on top of anyways, like Hugging Face and all those things
Yeah.
are just buying server time from AWS. They don't have their
Yep.
own farms.
And it can integrate
Yeah,
with other things that you
yeah,
do.
yeah.
Yeah. There's an internship question that I want to touch on.
Okay.
What type of internship will recommend? I think I would go for big and small. Small companies have, like startups have internships. I'm sure Lightning had some internships.
Hmm.
Cohere had internships that you should apply for. And the big ones have a bunch of like research internships you should look at. Facebook, Google, Apple. There we had a research internship. So I think you should definitely apply for all of them, like really
Yeah.
just throw in summer internships can be pretty good. I see a lot of people who end up with a full-time career that stemmed out of an internship.
Another thing that I've was, and this is in the Stone Age back in the day, but one thing I found helped me out a bunch is, a lot of those internships can be really competitive, like Microsoft and all those companies. Like, sure, they've got internships, but billions of people are applying for those things because they're super awesome and choice.
Hmm.
I was never ever successful in getting any of those. But what I did is I just walked around and said, "Who needs computer help?" And I
We'll do
always found
computer for food.
exactly. I found myself doing some of the coolest things ever. I got I was I used to, and I ended up, for example, one of the things I did as part of like one of these, like maybe an internship where I was just wandering around with a computer, is I ended up coding something for a neonatal intensive care unit. So when babies are born prematurely, if they're born really prematurely, then um, they can't feed the way they would normally do, and they have to be fed a very specific diet. Balancing salts with potassiums with all these things, and it's actually a lot of complicated math. And back in the day, all the doctors were doing this math by hand, and it meant for lots of errors, and you don't want errors on these little tiny babies because they're so cute. And
No.
so I wrote a little program that just did the math for them, and it was like do DIY internship, right? And as a result, I had this sweet, it's like you put that on GitHub, you've got this sweet resume. I mean, it's maybe you didn't make I didn't make any money doing it, but I had something to show for my effort, and that led to other jobs and other opportunities for me. So I'm always like, sure, there's great internships out there. Apply for all of them. You might get one, and if you do, that's awesome. But you don't always have to look far away for interesting projects. Just walk around the halls of, if you're in
Hmm.
school, especially if you're in school, just say, "Hey, professor, uh, can I help out on something?" And
Hmm.
they might say, "Hey, let's do it." I had a lot of cool projects that way as well.
That's cool. Yeah, I talked to professors when I was in undergrad and said, hey, can I help you in the summer? And that's where I did my summer internships.
Yeah,
I liked what you did. I mean, I feel like another thing is if there's a project where you can help the world, definitely or
yeah.
help other people. That I feel like that taps into a source of energy that's infinite. If you're doing good for others in your project, it can go very far. So I encourage everybody to find that.
Yes. And so I have some bad news. We're coming up to an hour, and I have to end at an hour. Uh, so before we go, one, I just want to know, would anybody be interested if we did this again? Should we do another one of these Q&A live streams? You can post that in the chat. Let us
Say
know.
yes in the chat if you
Yeah,
would like
say
to.
yes because I had a lot of fun. We might do it no matter what. Well,
I think so. Yeah.
Zero popular demand, but me and Lewis are just having too much fun.
I would love that. We just go on a Zoom and just broadcast it. And
exactly. So it's a little bit of a rhetorical question because I think we're going to do this no matter what.
We will
But
definitely
anyways,
do it.
so we're going to do this again. So look out. We'll be posting, and I actually have some travel coming up. So maybe we'll shoot the next one. Maybe we can do it in June, early June or something like that.
Yeah, let's do it. I'm down.
Okay, Lewis, we'll plan it for early June.
June.
And we'll get more questions. And I know a lot of you guys, I'm seeing a lot of questions we didn't get to. And I think the best way for us to get to your questions next time is we'll be posting on social media. I'll post on YouTube. I'll post on Twitter. I'll post on LinkedIn. And Lewis will do that too. That's the place to post your question because that actually gives us a little bit of time to think about it.
Yep.
And we can ingest it.
We can do RAG.
And RAG. And so, and exactly RAG. And Lewis and I, we met a few days ago just to discuss the questions and kind of, or we emailed a little bit to discuss what we were going to do, come up with a game plan. And so if we see your question earlier on, you're just going to there's just so much higher chance we're going to get to it. So, so with that said,
yeah, the song.
Hooray! Thank you for listening to me and Lewis. We had lots to say. Hopefully some of it was helpful. Hooray! Hooray!
Hooray! Double bam!
Double bam! Yeah, that's right.
Thank you, Josh. Thank you,
Starmer,
everybody.
Lewis Serrano. Double bam hour.
Thank you.
Yeah.
It's been an hour. Thank you.
Oh, and
thanks,
by the way,
everybody.
everybody check out Lewis's YouTube channel. We've been talking about it, but check it out. It's awesome. I'm going to put a link in the comments below.
Thank you very
because
much.
he's got great stuff. All right.
Thank you.
So with that said, bye.
Bye, everybody.